theme. Yeah, I'll get it. Welcome in. James M. Nucley here, Premier Research Scientist for Whalebone IR and Software, where the future is only 2 days away. Makers of fine pens for the Wii whiteboard system. Today we're going to cover Algebra 1 Standard, the laws of exponents. It's the law. You better learn it. Come right this way. Now the standard itself says only this about the laws of exponents, that they, you, that is they, you know, students, you guys, they, that's you, understand and use the rules of exponents. Now, there are a lot of rules of exponents. With that one phrase there, they say a big mouthful. But don't worry, I'm going to get right on it, and I'm going to show you all the rules of exponents, and you're going to learn them, and you'll have no trouble. So here we go. Laws or rules of exponents. Whenever we have a variable which contains exponents that have equal bases, we can do certain mathematical operations to them. Those operations are called the laws of exponents. Basically, this is like a game that we can play when we have exponents and we have the same base. This bigger number here that's being taken to the power or being taken to the exponent, that's called the base. So B for base, I got a B right there. The x is the exponent, sometimes also called the power. Boom. That's it, folks. Memorize that and you'll be okay. Those are all the laws. I told you there was a lot of them. We have the multiplication law. X to the m power multiplied by x to the n power is equal to x to the power m plus n. So when we're multiplying exponents, we add them together. X to the power m, then taken again to the power n, is equal to x to the power m times n. In algebra, when we put things right close together like that, it usually means we want you to multiply them. Here's another rule. xy, that whole quantity taken to the m power, we can kind of use a distributive-like rule here. We can distribute that m to the x and that m to the y. The final result is x to the m power and y also to the m power. Rule number 4, x over y, take that whole thing to a power m. We can once again kind of distribute the m to the x, distribute the m to the y. Our final result is x to the m power over y to the m power. I know I'm going a little fast. Don't worry, I'll slow down in a bit, and we'll go dig into them a little more deeply. But this makes a good review. If you want to roll back the tape to this point and get it all quick, here we go. If m is greater than n, and you have something like this, a fraction with m on top and n on the bottom, you can simplify it by subtracting n from m. Or in other words, subtract the lower number from the higher number and you'll get a result. This only works, keep in mind, most of these rules require that you have the same base. This x and this x, they're the same letter for a reason. It means that this has to be the same thing for x and the same thing for x here. These two don't have to be the same thing, but they could be. Now, if n is greater than m, then we leave the result on the bottom of the fraction and we subtract m from n. So we put a 1 on the top and we take the m away from the n, we get x. I know I'm going a little fast. I know this might be a little bit confusing right now. I'm going to dig in more. Hang in with me. Here is the other properties of exponents. X to the 0 power is defined to be equal to 1. X to the negative 1 power is equal to 1 over x. So we put x on the bottom of a fraction. Its understood power is a positive 1, but it's equal to 1 over x. Any single number or variable is always to the first power. Just like with square root, if there's no number there, we understand that we have the second root. Same thing here. If I just have any number like 3, I could write it if I wanted to as 3 to the first power. If I have any number a, I could write it as a to the first power. If I have any complex expression like x squared, that's equal to 2x, I should say. Sorry about that, not x squared. 2x. We have 2 to the first power and x to the first power. Altogether we have, or we could say it as 2x, the whole thing to the first power. Moving right along. Here's some basic examples of actually applying the rules. So we're digging in, actually applying what we've learned here. Here we have x to the second power and x to the third power. We would apply the multiplication rule or law of exponents here. Notice I have x and x, they're the same thing, and then think of this as the n that we talked about earlier, and this is the m that we talked about earlier. So we're taking m plus n, adding them together, and our final result is x to the fifth power. 2 plus 3 is 5. So x to the second power multiplied by x to the third power is actually x to the fifth power. If you plugged in a number for x, you'd get the same exact result from this as you would from this. You can do it on a calculator or do it by hand, but you'll get the same number if you do the same thing. Here we have a power to a power rule. Anybody remember what we should do here? Because we're taking this power to a power, we actually have to multiply the 4 by the 3. 4 times 3, we get x to the 12th power. This and this mean the same thing. They will come out to be the same exact number. Here is xy to the third power. We would distribute the 3 among the x and the y in this situation. So we get x to the third times y to the third. Some more examples. Just basically going through each of the laws that we saw and doing an example of it. Here's x and y, all to the third power. Notice this whole thing. I've got parentheses here. So I don't just put the 3 on the x and think that I'm done. I don't just put the 3 on the y and think that I'm done. I have to put it on both. And I get something like this. X to the third over y to the third. Moving along. If I have x to the seventh power and x to the fourth power. Now this is a rule that's used all the time in Algebra 2 and Calculus. So learn it well. Notice that I have x and x, the same thing. So I can get rid of these 4 x's on the bottom. But in order to do that, I have to take away some of these 7 x's that I have on the top. I subtract the 4 from the 7. Final result, I'll get 7 minus 4 equals 3. So I get x to the third power. I don't have to write the over 1 anymore because that's understood. We have x to the fifth power over x to the seventh power. Here, the bottom number is larger than the top number. My n is larger than my m. So I apply a rule where I move everything down to the bottom instead of like here where I moved everything to the top. I subtract my 5 from my 7, as you can see here, and my final result, 1 over x to the second power.
Oh, that's a good place to stop to get under our YouTube 10 minutes. Here's a little bunny rabbit for all your hard work. Please continue your studies with the Laws of Exponents Part 2. Because, this was Part 1. So, naturally, next one, you get it. Bye.